northern supercontinent, splits into North America, most of Eurasia, as well as Greenland. Gondwana, down in the south, splits into South America, Africa, Madagascar, Arabia, India, Australia, and Antarctica. So it splits into a number of different land masses there. And as they separate, the continents continue to sort of drift apart. By about 5 million years ago, most of the continents you can see, they're relatively close to what we recognize today. They're definitely recognizable as the planet Earth as we know it. You will see, I mean, there are some big differences here. So places like India hadn't actually connected to Asia, so this sort of subcontinent down here wasn't part of that. How many of you guys have been to India, seen the Himalaya mountains? Okay, a number of you. So those mountains formed during that connection. They are very young mountains, which is one of the reasons that they are so high. And I'll talk about that a little bit more momentarily here. But first, I just want to mention one other sort of major event that really took place after most of these continents had found their current location, once they'd come to their current location. So that's the reconnecting of North and South America. So this is the Isthmus of Panama here, right? This is the isthmus around 20 million years ago and around 15 million years ago. So you had water flowing freely, between the Atlantic and Pacific Oceans. Now, it's important to remember that North and South America hadn't been connected really since Pangea, right? Since Laurasian Gondwana broke apart. Around 5 to 10 million years ago, that gap closed. The Isthmus of Panama was created. It completely altered the sort of water flow patterns within the Earth. Also allowed a land bridge between North and South America for different species to migrate between the two continents there more easily. And by the last ice age, all of the continents were in their current locations. The Isthmus of Panama had been created. Now, the exact extent of the land was slightly different. So you can see in this area that we've been traveling, right? South America right now is quite a bit thinner down there, whereas back during the last ice age would have been a much larger landmass, and that's basically because a lot of the water making up the oceans was trapped as ice, right? It was trapped as all the big glaciers, the ice sheets covering various parts of the world. Now, it's important to remember that movement is still occurring today, that this isn't something that just happened in the past and that we're done with, that we don't necessarily have to worry about. I wouldn't worry too much about forming a supercontinent during our lifetimes. But it is still moving, and we do definitely see the effects of it. I mean, things like earthquakes and volcanoes are because of the geological movement. So we know that all of these move, and we know that they affect the Earth, or they have affected the Earth around us. We haven't really looked at how they move yet at this point. So most of the movement occurs within the crust and the mantle, right? Those sort of top two layers of the Earth there. And again, that brings us back to the asthenosphere, which is that layer of sort of molten rock that splits the mantle there. And that's what allows the plates to shift. It gives them that liquid base so that they can move. Now, the exact sort of motor behind this movement, the geodynamic mechanism, if you will, isn't completely understood. Scientists aren't quite clear what's causing the movement, but in basic terms, it has to do with the densities, the different densities between the layers. The heavy materials are going to sink, the light materials are going to rise up. There's also a certain amount of dissipation of heat from the mantle that causes convection and upwelling sort of within the different layers, and that's thought to have some effect on the movement as well. But really the effects as we see them really depend on how the plates come together, exactly how they're hitting each other or moving away from each other. So you have a couple different types of plate interaction here. You have convergent boundaries, which is basically where two plates run directly together. Now, when one goes under the other one, which is what you see here, this is known as subduction, right? And that does have a tendency to create volcanoes here as well. Now, when they run into each other, just sort of straight on, it's considered a continental collision, and a lot of times that's what creates the large mountain ranges, right? So they hit each other, and all of these mountains are sort of formed along the area where they're either pushing up the land from underneath as one passes under, or where they're sort of pushing up at each other. Now, divergent boundaries, I'm not going to spend a lot of time talking about, but it's basically where the plates are moving apart, and it creates giant sort of ridges, gaps. It can also create some mountains in there, but there's a big sort of gap being created in the mid-Atlantic Ocean as the two plates move apart. In sort of East Africa, the Great Rift Valley is another example of plates moving apart, and it's thought that eventually all of the land to the east of the Great Rift Valley will sort of separate as its own little island. I say eventually because remember in geological time periods, we're looking at millions of years, not decades or centuries, millions of years here. Now, transform boundaries are when plates sort of slide or grind against one another, and that's probably the interaction that we're most familiar with on a general basis. That's what creates the fault lines and the huge earthquakes that we see in various parts of the world. And in particular, we see a lot of earthquakes and volcanoes along this sort of ring that you see here, the Ring of Fire. And I'm sure everybody's heard of the tectonic activity within Chile, so along the west coast where we started out and where we began our journey, there really is a lot of activity there. It is part of the Ring of Fire, this area of highly active tectonic features of lots of earthquakes and volcanoes. Now, the most obvious one probably is the mountains that you see along there. That's the one that we encounter the most easily. But you do also get a lot of sort of rather drastic effects. So the mountains are a much more long-term effect. So they are extremely impressive. They are the world's longest mountain range, the Andes here. They're about 7,000 kilometers from north to south, 4,300 miles long, and 200 to 700 kilometers wide. Now, the earliest formation of the Andes, of the Andean mountain range, actually dates back to the time of Pangaea. So to when all of these continents were still together, and you had a lot of small plates that were still interacting with this large continental piece here, the supercontinent. Even once Pangaea sort of broke apart, once you get Gondwana and Laurasia, you still have a bit of action with these mountains forming, but they really began to sort of take their current form back in the Cretaceous period, which is about 145 million years ago. Now, the rise of the Andes hasn't been constant, and it hasn't been the same throughout the range, right? So that various parts of the Andes, you get the sort of northern, central, and southern sections here, and various parts do look quite a bit different depending on exactly how the continent, the plates there have affected them. Now, you can see here that again, it's this boundary, right? The sort of boundary between the Nazca plate, the South American plate, and the Antarctic plate down here. You have, right down in Chile, you actually have three separate plates coming together. So you do get very dramatic mountains through that area, but you also get very dramatic earthquakes through that area. So subduction, the process that's taking place as the Nazca and Antarctic ice sheets, or not ice sheets, continental plates are pushing under the South American plate, that's also responsible for the earthquakes and volcanoes that we see in the region. Right? Again, along the Ring of Fire really has a much higher density of volcanoes as well as earthquakes than just about anywhere else on the planet. Chile alone has over 50 volcanoes. Right? So they're dotted all through the fjords, so those mountains above the fjords that we saw, filled with volcanoes. Now, in very basic terms, a volcano basically occurs sort of as that subduction occurs, the land, the shelf that's being subducted there releases some water, and that actually ends up lowering the melting point of the mantle above it. So you get this molten rock, this magma. Now, when the magma is sort of forced to the surface, spouts out, that's obviously when we see a volcano. Now, do you guys know the difference between magma and lava? It's not really all that important, but it's one of my sort of pet peeves here. Magma is molten rock underground. Lava is the same molten rock once it's above the ground. Right? So it's magma before it comes out of the volcano. Once it's been released, then it's lava. That's just my own little spiel there. Now, again, earthquakes, you also get huge numbers of earthquakes, and over the last couple of years, we've seen a number of earthquakes within Chile, some very, very large earthquakes, as well as other places along the Ring of Fire there. But again, that's because these three plates converge, and as they're moving, they're sort of grinding against one another as well. And once enough pressure sort of builds, the plates slide, and that's where we get these really sudden and often devastating earthquakes that really can't be predicted by scientists at this point. There's no method for really predicting exactly when one is going to happen. Now, that's sort of the basics of the geology of the world, as well as a little bit about South America and the formation of the land that we've seen. But geology, again, it really does influence more than just the mountain ranges and the earthquakes and the volcanoes. As I said, it sort of creates the soil types as well, so that as these minerals and rocks are brought up to the surface, they're sort of washed away by erosion. Within South America here, they're fed into the Amazon basin here, so you get a lot of different minerals from the Andes that flow down slope to the Amazon basin. They also alter the wind patterns, so that you get different areas of moisture occurring, the Amazon basin being extremely wet, as well as some on the slopes of the Andes there as well. They create areas like the Drake Passage, which we pass through, that have amazing amounts of biodiversity within them, but also fairly rough seas, which has a number of cultural influences, and as well as the biological influences that you see there. So, I mean, really, geology is the basis for the world around us. And I don't know, I think just the fact that you guys are sort of on this cruise, I think, means that you're interested in exploring the world around us a little bit, learning a little bit more about the world. And I really think that geology is the place to begin for that. So I hope that's been a good review for all of you. Thank you very much for coming. And again, my name's Benjamin, part of your exploration team, and don't forget to check out all of the other cool activities going on board the ship.